Next is the relational database. An array relation. Let A1, A2, An be sets. An array relation of these sets is a subset of A1 cross A2 until An. A1, A2, An is the domains, while n is the degree. For example, let A1 be a set of names, A2 a set of addresses, and A3 a set of telephone numbers. Then a set of three tuples name addresses telephone numbers, such as this example is a ternary or ternary relation over A1, A2, and A3. Primary key. Primary key is the domain of an n-array relation whose values uniquely determine the n tuples. No two records can have the same value from the same primary key. For example, the primary key from four tuple suite of fields student name, ID number, major and CGPA is student name and ID number. Composite key. The definition: combination of domains can also uniquely identify n tuples in an n-array relation. When the values of a set of domains determine an n tuples in a relation, the Cartesian product of these domains is called a composite key. For a relational database, a database consists of n tuples called records. Each of the n tuples is called a field. Fields are entries to the n tuples. Operation on an array. First one is projection. Pi1, I2, Im maps the n tuple A1, A2, An to the m tuple Ai1, Ai2, Aim, where m is less or same as n. Second one is join, where it is to combine two tables into one if they share some identical fields. Now we move on to equivalence relation. A relation on a set A is called an equivalence relation if it is reflexive, symmetric, and transitive. It is to relate objects that are similar in some way. Two elements that are related by an equivalence relation are called equivalent. Equivalence classes. Partition. Let A be a set and A1, A2, An be its non-empty subset. The subset from a partition P of A if the union of the subset in P is equal to A, the partition P does not contain the empty set, and the intersection of any distinct subset in P is empty.